Salam and okay, salam and thanks for everybody who is joining us today on this important topic about the role of mathematics and data science in the field of data science. And we have the Dr. Saad, an eminent professor at the University of Minnesota, joining us today for this important topic. But before we start, I just would like to go through few slides to introduce the Algerian American Association for Science, Technology, and Entrepreneurship. It was founded by a group of Algerian American scientists in 2020, and I'm very happy to see Khaled, who was one of the founding members, being present today. And as stated, the goal is to serve the scientific community both in the US and in Algeria, and to develop strong working relationship and partnership between universities, academic institutions, business community in the US as well as in Algeria. Briefly, the goal is to serve as a link between the Algerian American Association here in the US and Algeria. Currently, we have over 100 members spread out all over the US. Our goal is really to reach 200 members by the end of the year. We are working hard to achieve. It's a US non-profit organization registered under IRS regulation 401c3. So I go here briefly about the vision that I think mentioned before, it to advance the role of science, technology, and entrepreneurship. And how we are doing that is to mobilize scientists, professional, academic institutions to really achieve that vision. And ultimately, the goal of the association is to really make modest contribution to the creation of a knowledge-based economy and the advancement of science, technology, higher education, and research in Algeria. Currently, I would like to introduce, so we have board member that spread out from different background and location. Probably some of you know Lakhdar. He's the president, he's the director of international relations at the University of Florida. And then myself, some of you, I'm sure, a lot of you have known me, so there is no need to go to give further details. Then we have Miriam Belabed. She leads the science group, and she is a postdoc student at Mount Sinai in New York. Hakim Maloufi, he is an MBA student at Columbia. He's going to finish soon and join the Boston Consulting Group in Washington, D.C. And then Omar is here. He's PhD student in the University of Utah. Fatima Brakta is a pharmacist and located in charge of the scholarship and award group. Is located in New Orleans. The money man, Rashid, is works for an international development agency in Washington, D.C. And Nazim is in charge of his PhD student also, I think in Boston, University of Massachusetts in Boston, and in charge of the student group. So that's basically the current management that we have. So we are structured, we have three, what we call working group, which are the focus of the association, which is science group, technology group, and entrepreneurship group. Each one with a leader and a couple of members. And then we have two standing committees, one on scholarship and award, and the other one for student initiatives. So I don't want to use more time. I would like to let Khalid take over from here, and then introduce the speaker as well as moderate the webinar.
Thanks, Mohammed. I'll be brief. Good afternoon, everyone. Good evening in Algeria. I am Khaled Bonar. I'm really honored to introduce Professor Yousef Saad today, who's going to talk to you about applied mathematics in data science, and as it relates to also artificial intelligence, which is, as you know, a hot topic nowadays. Dr. Saad is a distinguished professor of computer science and engineering at the University of Minnesota. He's been there for over 3 decades, I believe. He's a SIAM fellow, and he's been for quite a while. SIAM is a Society for Industrial and Applied Mathematics. He's been awarded the chair of the William Norris Land Grant in large scale computing, and he's been granted that for over 2 decades, maybe. Last year, in 2023, Professor Saad won the prestigious SIAM Van Neumann Prize, recognizing his fundamental contributions in scientific computing. This is actually the highest honor by the society. And we are honored for that. Dr. Saad's work on algorithms in data science stems or covers a wide range of problems, including sparse linear systems, eigenvalue systems or problems, nonlinear equations, and graph algorithms. I would think, or I believe that anyone working in scientific computing should read his books, buy them to help him out on applied mathematics. One is the iterative methods for sparse linear systems, and another is numerical methods for large eigenvalue problems. I don't want to take more of my, this time, but I want for the audience to use the chat window if you have any question, comments for Dr. Saad. And he will he'll respond to them at the end of the lecture, I believe. So, and please keep your mic muted during his lecture. Without further ado, here's Professor Saad.
Okay, thank you very much, Khaled, for introduction. Assalamu alaikum, azul bonsoir. So I'm gonna start sharing the screen, I think, here right away. Right there. Sorry about that. Okay. So actually, I was not 100% sure what I would talk about because the audience is broad and everything, and I don't want to get too much into detail. So the main point I want to make this evening is the fact that mathematics and in fact science in general is changing directions, and it's very important to be aware of this. And then we'd have to think of what impact has on your own, whatever you're doing, research or you're an entrepreneur, whatever. So it's very important to be aware of the changes. So historically, here is how my own field has evolved. So it has been influenced by a number of factors. For example, in the 40s and 50s, there was a major issue in aerospace engineering, which is called the flutter problem. So these airplanes at certain speeds will start losing their wings. So it was a very, very big problem. It had to resolve that. In fact, this was especially for the military, actually, because these planes would go at certain speeds, and this gave rise to a lot of effort devoted to eigenvalue problems. How do you resolve these issues with oscillations and so on? So these are really some of the works that have led to a number of packages and so on. And then in the 60s, there were problems with the power grid. So these are you probably have heard of these very major power outages. One of them in the eastern side of the United States, maybe 3 decades ago, and another one in Europe, where the whole system was shut down because of an instability in the system. So people started looking at that in the 60s, and then this gave rise to sparse matrix eigenvalue problems. I'm going to try to remove that thing from here. Give me a second here. Yeah, right, here we go. Okay. So in the 70s, of course, came the automotive industry, aerospace, where computational fluid dynamics was a big thing. And the late 80s, a lot of work on parallel computing. Okay, I'm going to talk about that in a second. And then late 80s, you had financial computing that came in force, and then it disappeared a little bit later. And then, of course, the current wave is AI and machine learning. So here's a very simple illustration of the very first wave, which is called first wave of computing, a fluid flow. For example, when you design an airplane, you do something like this. You try to model the fluid flow around the airplane. In fact, when I was at REACS and NASA Ames in the 90s, I saw those very big wind tunnels that they were using at the time to do the simulations. It turns out those are really, really huge, like huge hangars, and you'd have airplanes in there, and then it would consume a lot of energy. And then just around that time was the first time when the whole airplane was designed entirely numerically without wind tunnels. So it was a very important achievement. It was actually one of the first Boeing, forgot which of the Boeings, that was designed entirely by computing without doing the, so you have to really trust the computing to be able to design a plane like that. So that tells you that they achieved a lot of expertise in this area. So this is a typical problem. Then you have eigenvalue problems. Also, this is another kind of really complex kind of computations you can have. This is an example we worked on, again, a few years back. This is in quantum mechanics, where you have, these are really the problems that consume the most computer time in computer centers in the world. You have very, very large problems, and you compute a lot of eigenvalues. And so this is a silicon cluster. You're trying to model what is called this electronic structure, and this solves Schrodinger equations and so on. So these are really big, big calculations. And then just around 1990, started a second wave, what I call the wave of data mining. So essentially, how do you exploit data with computations? Many of you are aware of how Google started. Very interestingly, Google started with a very simple idea, which is the one that's illustrated here. You have a network of computers or whatever, and they're connected with this graph. And you can jump from one node to the other with some probability. And you could ask the question, what is the likelihood of being sitting at any given node here after a very long time? This is called the Markov chain model. And two very bright students at Stanford had the idea of using this to rank websites. At the time, it was just the beginning this was just the beginning of the internet, actually. So you have to realize that this is really at the beginning. It was very important to be able to decide which node is more important than the others. And these two students, Sergey Brin and Larry Page, had this idea, and they got some funding, and they started this. And now Google is one of the biggest companies in the world. And this is a very simple eigenvalue problem in the end. Okay, so that's the very first, one of the first instances of what I call the era of data mining. So essentially trying to get mine the data for some gains. And this is another application. This is more recent. I'm going to just go through it very quickly. Have a network of people who are influencing each other, and so these companies actually try to set up the prices in such a way that they will profit from these guys who are influencing each other. So, for example, if you're someone who have big influence on other people, then they will give you a very good price. That way, people who are following you will buy essentially the same product, and you can make gains that way. So this is a very interesting problem that's somewhat similar to this thing, actually, ranking and things like that. And this is something called the Bonacci centrality and so on. So all in the same idea of social networks and graphs and so on. This is another illustration of something that I found when I encountered this the very first time. I found it to be very fascinating, graph embedding. You have these social networks, again, with people connected to each other, and you would like to visualize that in 2D on like a sheet of paper on the plane. So you'd like to project it. And this is one application, of course, but there are a lot of applications where you'd like to embed this graph into certain vector space in such a way that you can use it even in machine learning methods that use like that deal with language models, for example. This is very much used. It's a very, very important problem. I'll give you an illustration that's very fascinating. So imagine this picture of this teapot here, okay? And what you could do is you take 180 different pictures, one for each degree, 1 degree for degree 0 to 179. Okay, so those are. And they take a picture of these angles of the same teapot, and then you scramble all the data, so you don't know which one was which, and then you ask the system, which is in this case a method called eigenmaps, to project that into a plane, and then you look at the picture, the corresponding teapots that you have seen on the plane, and interestingly enough, what you'll find is that they're ordered exactly by the degree in which they took the picture. So this is degree 0, degree 1, etc. And it's almost on a perfect circle. So it's quite amazing. So you're discovering something that is hidden in the system. You're discovering what this is called a manifold that's hidden in the system by doing this. And it's a very simple illustration. There are many others like these. And then came neural networks. So this is a problem. So this deals with the problem of trying to classify something. For example, you have a number of images, and you would like to know what they are. Is this a cat? Is this a dog? Whatever. So, and then you're putting. So what you do is you're putting your training data. So you have your sets here, and then this should be the answers. So what you would like to do is you got a function that goes from here to here, so that you get the correct mapping. So your every data item here is mapped into one of these outputs in here. So you're trying to minimize essentially essentially to make sure that the function you're developing this way is optimal in the sense that it gives you the right answers as best as possible. So this is the detail of how it works, the initial idea is rather simple. This is trying to imitate how the brain works, essentially. So, but the mathematical problem is fairly simple to describe. It's you have a function, which is you call phi, this function, which is described by a set of parameters. These parameters are the parameters that link one level to the next. Well, those are sort of matrices and so on. And then at the end, you get the function. This is a loop that gives you go from the input to output. And you'd like to optimize the W's, the parameters, in such a way that the answers are correct. So Y is close to the mapping phi of the X you started with. That is essentially how neural networks work. So it's very straightforward in terms of ideas. There are two things that were really that made this possible. At the time, this was in the 1990s. It was seen that it was a nice idea, but there were challenges. The calculations were very hard, very, very, very challenging, essentially time-consuming. So this was one of the problems. And then the data, they had to essentially make sure to have enough data. So that's the reason why it had a lot of, it was time-consuming. The other problem was that calculations were not so obvious. So there was two inventions that made this possible. One of them is something called backpropagation. How do you calculate derivatives easily? That was one thing that really made this doable. And the other one is the compute power. So essentially, the exploitation of what is called GPUs, graphical processing units, and those are essentially boards used for games, for gaming, right? And it's discovered that they could actually be helpful in this context. And then, so that's how NVIDIA started. And then it became extremely popular. Now NVIDIA is a very, very, it's actually gaining importance every day because it's being used a lot in these problems. Okay, so that's essentially the neural networks. So at the beginning, this was not very popular. It was seen as, something that was a little bit too far off. Now, maybe it will not work someday, but it's not going to be very useful today. It could be, it's a nice idea, but it's not for today. And then later on, people started to come back to this, and they discovered that putting a lot of layers made a big difference in the results. And then they discovered also that with the compute power, you could do the computing now in a reasonable amount of time. That's really what made the difference. And this started becoming popular again around maybe 2005 or something like that. So this is just some comments about that. The problem is well, these are from the optimization point of view. You have a lot of parameters, and then these are methods that are used. Training could use GPUs. So what I call training is essentially getting these parameters here, computing, optimizing the system to get parameters given data. And then starting in 2017, there was a huge development in large language models, which is called large language models, because of a breakthrough essentially in the performance of some of the systems. It was really, really major breakthrough. So BERT was one of them, GPT-1, 2, 3, etc. And then now we have all the way to GPT-4. So these are all the systems that are being used. There are quite a few of them. Which brings us to the new wave. And this is what I call the ML AI wave. This is an interesting read. For some of you can have access to this book. It's I found it very interesting to read. This is by, the author is Mustafa Suleyman, who is the co-founder of DeepMind. The DeepMind is the company that defeated the human being in the game Go, which was a few years back, I think 2017 or so, or 16 perhaps. So what is the topic? What the book was saying essentially was that there was amazing, really astounding progress made in the last few years. And I will tell you a little story about that, because really it is amazing how fast this thing is progressing. With a huge acceleration in the past 6 to 7 years. And then this is caused by synergetic forces. Hardware is one of them. Openness, the fact that this is all, everybody is participating. And then the focus that everybody's looking at the same problem. And I think the thing that really is kind of a little bit disappointing about the book, actually, is that a lot of the book had to do with containment. How do you contain this thing? Because this person and many others are very, very concerned about AI. And you could tell that in the book. There are some stories that are really kind of scary. You know, it's going to be, you have to be very careful about what could happen. Okay. So now the story I was going to tell you about this is about this progress is just in our department. Just this last semester, there was a faculty member who sent an email saying that last year he thought that students were not going to be able to profit too much from ChatGPT and doing their homeworks. And this year he changed his mind. He said it was a big problem because he gave a question, like a problem that he gave to homework as a homework to his students. He just showed the picture and asked the system, ChatGPT-4 in this case, to give him an answer. And he was completely surprised by the answer. Not only was it able to read the question, because this is a question with diagrams, and it was something in robotic was not obvious at all. But he was able to answer the questions, and including one which was very, very clever, where he did a very, very clever answer. So he was completely surprised by that. He says there is a big issue. So one thing that I'd like to compare with is with Moore's law. Some of you may know about this law. So this was about the, actually, I guess maybe. Okay, yeah, so there's questions. I'll ask these questions later on. So the Moore's law came about in the 60s, where they were comparing, they were looking at the progress of hardware. And the law is very simple. It says that the number of transistors placed in a chip doubles every 2 years. And this was stipulated in the 65s, was modified a little bit, and it was very accurate. And you can see also similar trends in every technology, okay? So technology progresses in. So let's look at this. This is what you see from the Moore's law. It's very linear, this logarithmic scale. And this was a very accurate model up to now. We started to really have a problem. It's flattening it down a little bit here because we're reaching the limit of what physics can do with transistors. What about AI? Well, in this case, it's no longer transistors, it's the number of parameters in the large language model, some of these AI models. So we don't have too many reference points, but you have 5 of them. It could be enough to start doing something similar. When I did the calculation, this is a very simple thing done in MATLAB. You'll see that you have a doubling every 4.3 months. And then there is a factor of 10 every 14 months, very different from this, much faster than what you have here, right? A lot faster. So the trend is much faster than Moore's law. By the way, just to give you an idea, the number of parameters in GPT-4 is 100 trillion, 10 to the power 14, an enormous amount. And this between GPT-4 and GPT-3, I think I have the numbers here probably somewhere. Well, I have it somewhere else. Anyway, it's 175 billion in one of them, and then it gets to 200 trillion parameters. Quite amazing. So the main point I wanted to make in this talk was about this precisely. AI is very disruptive. The students are interested in AI mostly. It's very difficult to find students, in computer science at least, who want to do anything else. On the education side, I mentioned this problem with homeworks. This is an issue, and it's having an impact. On research, the impact is obviously also very important because all the labs, everybody is pushing AI. So, in terms of what happened to our specific field, can we become irrelevant? Can a field become completely irrelevant? So I think we should still participate deeply as much as we can in deep learning, doing research in deep learning. But there are some differences in culture and everything. It's a challenge. I think really it's kind of a transformation that is really disruptive, and it is causing difficulties, I would say. So these are the main ingredients that are used in deep learning. Optimization is one of the main ones, statistics, numerical neuroalgebra, graphs. Then you also need to be able to code, things like PyTorch, etc. So, well, the good news is that everything is online. There are a lot of online resources. Chip making is very competitive, and there's very, very protected technology. So it's very difficult to know what Taiwan Semiconductors or ASML are doing. They're very protective of what they do, very secretive. In contrast, AI is basically 100% open. That is truly amazing. So you can get all the codes you want. Of course, the only limitation is you need to compute to be able to compute. But the codes are entirely open. This is this book I read a few years back, where they talk about the Linux and the open source versus the monolithic approach of the big companies like IBM or whatever. So talking about the cathedral and the bazaar. And essentially the bazaar was where everybody participates, right? And that's one versus the cathedral, where top-down approach. So it's a blessing for researchers and for science, but it's also a curse, as I mentioned the issue of containment earlier. Okay. The only requirement, unfortunately, is, of course, that you still have to be able to compute. To train these models, it takes days and months of computing. So the new era is really this popular, distributed, dynamic, chaotic, but big bazaar is winning over the monolithic cathedral. So how do you participate? Just a few thoughts to conclude. I discovered that recently that they actually teach Python to children in China. So I'm going to give you the page here. So kids take to coding at an early age in China, making it the child's play. So this is something that I heard from a colleague of mine. Oh, where is my thing now? I've lost it here. Okay. That you want to try. I said, my kids are learning this stuff at school. There are many resources available, tutorials for PyTorch, etc. I probably haven't heard of Core 42. It's a school in France, which essentially it's where you have entrance is free, everything is free. They're very selective, but you're just coding. You learn a lot of coding. And there are schools now everywhere. I think a lot of them all over the world. There are a few in Africa, in the US, everywhere. So this is something that's interesting. And then there are resources like this one here, which I think I actually do use this myself. This is interesting because it's a book that's free, entirely online. And it really is nicely done. These are the authors of this, entirely shared, and I think it's interesting to see who is using this. And by the way, these are the universities that are using it all over the world. And there are two in Algeria, actually. If you look at the map here, you cannot see it well, but I could show you which they are. Actually, let's see. One of them is in Septif, I think, or something like that. No. Yeah, no, I don't think. I don't have to know the name of this university. There are two of them. One in Sétif, one in Bourg-Barrage, I think Bourg-Barrage or something like that. They are in here. So you can take a look at that later and you'll find it. So, but anyway, there's a book. This book is quite interesting because it's nicely done. It has quotes. It has a lot of material that links to it, and everybody's participating in it. So you can see that people sometimes would see, for example, here, if I take a look here, people would put in some comments at the end, and so on. Very, very nicely done. Okay, so that's one thing. Just concluding remarks here and side comments. Good universities are powerful engines of development. Look anywhere and you'll see that good educational institutions create developed zones around them. There's no doubt that AI will play a similar role, but this time will be a more global one. And I've been looking at this recently, and I found that really what is amazing is there are some places that are really taking advantage of this, but not others. I think it's really important to see that there's some places in Africa, for example, are really good at exploiting this. I just mentioned this book just now, so some people are using it, and it's free. So let's see now. I'm going to take this by just asking a few questions here to ChatGPT. So this is the one, not the top one. I'm going to ask to show me the 10 recent startups. Show me 10 recent startups in Africa in the area of computer science. Let's do that. Okay. So I'm going to show me. All right. 10 African startups in computer science. The field related to computer science would be better, but let's see what the answers. Surely. All right, here they are. I'm not sure you can see this that well, but I'm going to try to increase it a little bit. Yeah, here we go. So you see Nigeria, Florida, Jomo, etc., Kenya, all these places, and some of these companies are really AI related, are fintech. All of them are computer science related. They're but I found, actually, I was disappointed to see that not too many from Algeria. So, and you can see there are a couple of sites. I'm going to say that in a second, but there are a couple of sites that show you, the major startups in all of Africa, and you could take a look at those and how much they are financed and so on. So let's see. Should I say top 10? This is basically the same, but there are some that there are a couple. I had another one. I think this one doesn't give me the right thing. I had another one which it gives me the funding for each of them, how much money they were able to gather and so on. So okay. So anyway, let me go back to this thing here. The next one I want to show you is the ranking of the universities, of African universities. So these are the top 50 universities. This is a US News and World Report, and they started not too far ago, not too long ago, ranking African universities. This is really basically, the site ranks mostly US universities, and there are a couple of other ones. But I found this to be very useful because it's simple. You can go through these, and they give you the criteria that they use that are here to do the ranking. Okay, and then they have a ranking here, which gives you the top. In fact, I counted about 70 universities altogether here, 70 of them. And I did not see a single Algerian university among the top 50. It starts at 55. The first Algerian university is number 55 among these 70 that are listed here. You have 4 from Morocco, 4 from Tunisia. You have a number from Ethiopia. You have a lot from Tunisia, Egypt, and of course South Africa, which is not too surprising. But Egypt and South Africa are the top. You have, of course, here you have Nigeria. You have, so all of these universities, are are kind of nicely ranked and everything, but you cannot, this is very surprising to me. Yes? Had some
Can you
comment?
visit us, Bobby?
Sorry?
A ver si tengo una cable.
Don't worry about it. I think it's, I wouldn't worry about it.
Are you worried about this?
No, it wasn't addressed to you, sorry.
Yeah, okay, all right. So anyway, so so this is just a comment I had. This is really interesting because it reflects on something. I mean, some places are putting a lot of investment in these things, and so there's another thing about startups, and this is another site which I found interesting. This is something which gives you. I had this report here. If you download, I'll just take a look at it here. And did I have it? I have it somewhere. Let me just go back to this thing here. Okay, so this one, what you do is you go here, and they will give you. I have it somewhere else actually. So. All right. So anyway, this one has the funding. I don't think I need to show that anyway. So this has the funding. The largest companies that are being funded recently in Africa, and it's really interesting to read. So I'm going to conclude here, and I will answer any questions. I think there's no point in continuing with this stuff. So what I wanted to just say is that higher ed is very, very important. It really is a big engine of development, and AI is changing everything, and you don't want to miss the boat. It's really important to get into these areas and have people. If you have a good university, you have very good students in these areas. They could start companies, and it's like an engine that's starting, and these companies will bring others that will invest and so on. So I think it's very important to push this. I'm going to stop here and answer any questions you have. Okay. Stop sharing.
Yeah. Thank you, Professor Saad.